So the new information, one of the new pieces of information here in 3.5 with these rational functions is we said we could get vertical asymptotes. So these are essentially going to be vertical lines, right, straight up and down, and they're going to kind of almost be like do not cross lines. They're going to almost look like there's little magnetic force fields or something that our functions in our graphs are sort of coming up against, and they can't move past, and they're sort of forced either sort of up to positive infinity or down to negative infinity. I want to start just sort of quickly with a version of sort of the simplest possible rational function, which would just be f of x equals 1 over x. Right? What's the sort of simplest possible version of like a fraction type function we could have where there's a variable on the bottom? Well, let's just do 1 on top and x on the bottom. If we do sort of like a table of values, I'm actually not even going to make a full table. I'm just going to talk sort of generally, right? So obviously here, right, x is not allowed to be 0. If I just like look at the bottom, right, the denominator is not allowed to be 0, so x is not allowed to be 0. We sort of said in our previous kind of setup video that wherever the bottom is 0 and the top is not 0, we should get a vertical asymptote. So the bottom here is 0, the top is a constant, the top is never going to be 0. So we've kind of hit that, again, in the most trivial kind of way. So in theory, we should be getting some sort of vertical asymptote here at x equals 0. What I'm going to do, you could sort of do this using the Desmos tool online, desmos.com, or any kind of graphing tool. You know, if you sort of tell it, like, make a sketch, right? Make a graph of the function 1 over x. Let's sort of talk through a little bit the type of points we would get. We'll sort of mentally do a little bit of a table, and we'll kind of fill it in and see if we can sort of make sense of what this should look like. So in theory, right, x equals 1. 1 over 1 is positive 1. Right, you get 1 and 1. If x is 2, you would get, right, kind of 1/2. It's 3, you get 1/3. You know, what happens here is as your x values get bigger and bigger, you get 1 divided by that value, you get a smaller and smaller fraction value. You never get 0, right? You're going to get, in theory, as you go out into the right, just sort of smaller and smaller and smaller, but you're never really going to hit the axis. That's going to be a horizontal asymptote for us. Of course, we'll sort of come back to that in the next video. If I go to numbers between 0 and 1, so if I start putting in fraction values like 1/2 or 1/3 or 1/4 or 1/5, if I do 1 over x, 1 over 1/2, let's write this out so we can kind of visualize it. 1 divided by 1/2. Well, right, dividing by a fraction, you're really flipping and multiplying, right? This should be essentially like 1 times 2 over 1, which would mean your output there is 2. So you're flipping your fractions. 1 over x is like a reciprocal function, right? You're sort of flipping all of your input values around and taking their reciprocals. So when x is 1/2, the value you get out of that is 2. If you had 1/3 or 1/4, you would actually get sort of 3 or 4, right? 1/10 would be 10. 1/100th would be 100. So as you get closer and closer and closer, right, 1 over 1/10 would be 1 times 10 over 1 would be 10. As you get closer and closer to 0, you're actually getting bigger and bigger numbers. And so what's happening here is we're getting this graph that sort of goes up and up and up and up and up the closer you get to x equals 0. So the smaller x you put in, right, some sort of tiny positive decimal number, you're going to get a really, really big number as your output. So what's happening here is this sort of magnetic kind of like push away, this sort of magnetic kind of repelling kind of thing. It's you know, in some sense your graph is trying to head towards this, and it's just getting repelled and sort of pushed away, and it shoots up to positive infinity, right? This is sort of going up to positive infinity. And then in this way is going sort of out and flattening out. If we put in negative numbers, we're going to get kind of a mirror image of this, right? -1 would give us -1, -2 would be -1/2. We get this same kind of graph on the negative side, and then it would sort of flip and it would do, right, -1/2, -1/10, yada, yada, yada. All those are going to give us sort of big negative numbers. And so what's happening here is as we sort of go towards 0 from the left-hand side, we're sort of heading down to negative infinity. So this is a vertical asymptote at x equals 0. So our behavior here is we kind of have, what we're going to do is mark it with this dotted line. It's tough to really do that here because it's right over the axis, but that's going to be our kind of go-to demarcation. And then the idea is we've got a function sort of coming in from one side, and it is sort of repelled and shoots up, and then maybe from the other side it goes and shoots down. So this would be kind of a negative infinity here and a positive infinity here. That's the 1/x example. In theory, we could have lots and lots of different things that happen. I guess lots and lots is maybe sort of overselling it. But you could have something where both sides agree. So maybe you have something where they both are sort of coming at it and shooting up to a positive value. You could have something, this is sort of a similar kind of breakdown of options to our end behavior from 3.2. You could have something where they both are sort of coming in and then they get pressed downwards, sort of a negative infinity and a negative infinity. This would be sort of a plus and a plus. This is kind of our disco option, right, where they're heading in opposite directions. And I guess somewhere here in the middle, could be laid out a little bit better. You could have something where maybe the left-hand side is going up to a positive value and the right-hand side is sort of coming at it and shooting down. Positive infinity there, negative infinity here. So visually, that's what the vertical asymptotes are going to look like. So obviously we need to know that. That's the type of picture we're going to get. So it's this sort of like catastrophic failure. The idea is if you divide by 0, the actual behavior of your function is the function actually sort of shoots off to space, either sort of a big positive number or a big negative number. It's getting sort of just blasted away from all the other values. It's sort of getting repelled away. Let's pause this video there. I'll do a second one where we sort of go through in detail finding some of these values and what could happen if we don't get an asymptote where we get one of these like gaps and holes. So let me do a second video where we actually run through some of those examples.